to make the weld. It's all the instructions that he needs. It gives the voltage, it gives the current, it gives the filler metal, it gives the joint design. It gives all of the variables. In fact, there's something called essential variables, which if you look in the code, depending on the process that you're using, there are different essential variables. And so if you're using gas metal arc welding, you look in the code, it says these are the things that have to be in your weld procedure. And if you change those, or if they're not in your weld procedure, then your weld procedure becomes invalid. You have to requalify it. The procedure qualification record is a record of the tests that were done to validate that procedure. And so every weld procedure that the welders use has to have been qualified by doing a series of welds and then testing those welds according to what the code says in section 4. It tells you how many bend tests you have to do and how many impact tests you have to do, depending on the material and depending on the process that you're using. But all of that information is recorded in the PQR, which needs to be kept with the weld procedures in order to qualify them. The third type of document is a welding or welder procedure qualification record. And what that is that's for the personnel. That's for the people who are making the welds. They also have to be qualified. And so the code also has provisions for what these people need to do in order to be able to weld to your procedures. And it's not as stringent. It's much easier to qualify a welder than it is to qualify a weld procedure. But there are requirements that are laid out in the code for what the welders need to be able to do in order to make qualified welds. So the acronyms up there are Weld Procedure Qualification Record, or I think the other one would be Weld Qualification Test Record. Basically means the same thing. We're running out of time here. So inspection is traditionally something that was done post-processing, but that doesn't work. That doesn't work with welding so much because problems during welding can manifest themselves at any stage. The quality can be compromised even before the welding begins if the joints are not made properly, if they're not fit up properly. And so as part of the inspection process, you need to be inspecting as things go along. And problems can be identified when corrective action is simple and inexpensive. It's much easier if this is misaligned to fix that than to weld it all up and then say, oh no, that was misaligned, we've just got to scrap that piece. And so visual welding inspection, what the CWI does is the basis for this weld quality control. So you can imagine that a welding inspector needs to be involved in the entire process. He needs to be involved prior to welding to do all these things, and you've got them there, so I'll just let you look at those at your leisure. He also needs to be involved during welding. He needs to be able to check what's going on. He needs to be able to check the root pass, which is the first pass that's put in. He needs to check the preheat and inner pass temperatures, which were important for the metallurgy that we talked about. He needs to make sure that those are being checked. And then after welding is when all of that actual visual inspection takes place. He does that by verifying the quality of the weld. Is there porosity? Are there cracks? He checks the dimensions because the dimensions are going to be specified. And he's going to review if there are any other requirements that need to be fulfilled. So when he's looking at the surface quality, since a weld inspector is only looking at surfaces, he's not actually using other NDT techniques. He can ask for other NDT techniques like X-ray or ultrasonics, But when he's doing his inspection, he's just looking at the surface, and so he's going to see things like porosity, incomplete fusion of the weld, or incomplete joint penetration of the weld. There's a difference between fusion and penetration that I'll mention in a minute. There's things like underfill or undercut, overlap, cracks, inclusions, and excessive reinforcement. And let me show you a few of those. See if that shows up very good. So if you can tell by looking at this weld, there's a bunch of little pores. Basically, they're gas bubbles that have risen up as the metal was solidifying. That's scattered porosity, and there's enough there. If you can see that picture, there's enough there that would probably violate the code. Also talked a little bit about incomplete fusion. So if you were making this V-groove weld, you were filling it up with a bunch of weld passes. These are all individual weld passes. What incomplete fusion is when you've got a little region on the side here where the metal didn't fuse, the weld metal didn't fuse to the base metal. This would be internal. Another way that you might see it is in something like that, where they didn't fuse to this whole side of the joint. That's incomplete fusion. Sometimes people will call that incomplete penetration. It's really not. It's incomplete fusion. What incomplete joint penetration is when you've got something like this, where this weld might be okay, but if it was called out on your weld symbol that it needed to be a complete joint penetration weld, and you didn't actually penetrate the middle there, then that's incomplete. Or if you were welding a V-groove like this and you didn't weld all the way through, then that's incomplete joint penetration. Undercut is something that we run into a lot. When you're making a fillet weld or a groove weld, a lot of times you melt some of the base metal and then it doesn't get filled back up with weld metal along the edges. And that can be controlled by the welder's technique if he's aware of what he's doing. But the code is very specific on the amounts of that undercut and how deep it can be and stuff like that. Another discontinuity which can become a defect is underfill. Basically just like it sounds, you didn't fill up the joint as much as you were supposed to. Not so much, because it's actually kind of at the top of the weld where you would be filling it up, whereas incomplete joint penetration is more, on this joint, if you didn't penetrate down here and you were supposed to, that would be incomplete penetration. If you didn't fill it up here, that would be underfill. There's another discontinuity called overlap. Basically, that's where your weld metal kind of overlaps the edge and it doesn't really fuse right here. And so that's called overlap, and that can be a discontinuity or a defect. Cracks, we talked a lot about cracks in metallurgy. Cracks are unacceptable. And there's a variety of types of cracks. You can have centerline cracks. You can have cracks along the edges. There's all different kinds of cracks, but basically the most important thing is that cracks are unacceptable according to the codes. You can also have slag inclusions. If you can see that there, It's basically something that's non-metallic. It's a piece of slag, or it could be a piece of tungsten, which is metallic, but it's not supposed to be there. It's anything that gets included in the metal that's not supposed to be. And we are pretty much out of time, but I just wanted to show you a few of the tools that are used as well. And I've got some up here. I don't have time to pass them around and let you all look at them. If you're interested in taking a look at some of these gauges, I'd be happy to show you after class, maybe out in the hallway. But this is a kit that an inspector might use. He's got a variety of measuring tools. He's got a flashlight. He's got a ruler, a magnifier. He's got some calipers, and he's got some specialty welding gauges. And just real quick, there's a couple of them here that I wanted to show you. This is an undercut gauge. It's got a little pointer on it that will press down into that undercut that we talked about, and then it's got a reading over here that'll tell you how deep that is. For undercut to be unacceptable, it has to be a certain depth, and so that's why you want to know the depth, and then you want to know how long it is as well. So that's why you need your ruler. If you're measuring the reinforcement or the top cap on your weld, you can use a gauge like this. Basically, this part slides up and down, and it just tells you how high your weld metal is. And then the one that I use the most is the fillet weld gauge. On fillet welds, you always need to know the size. They're always going to tell you what the size of your fillet weld should be. And so the leg size is this dimension right here. So it's from here to here is the size of a fillet weld. And there's a gauge that can be used for measuring that. And here's a couple of pictures. Basically, it's a little tool that's got a notch cut out of it of a certain size. So this is a 7/8 notch. If your weld's supposed to be a 7/8 dimension, you just run this along your weld, and if it touches that, or if it doesn't touch that, then you know it's the right size or not. So that's what they're doing here. Is this is a cross section of a fillet weld, and they've got their gauge and they just slide it along. Okay, and we are out of time. Like I said, if you're interested in taking a look at any of those gauges, you're welcome to.